Okay, in this question, we're asked to read the problem first. The average ticket price for a concert at the Opera House was $50. Okay, so that's the average ticket price. The average attendance was 4,000. So I'm going to just start doing a demand curve. So this is price, and this is quantity. So when I had a $50 ticket, the demand was right here, and that demand was 4,000. When the ticket price was raised to 52, okay, so I'm raising this to 52, attendance declined to an average of 3,800 persons per performance. Okay, so this little dot here is at 3,800. So it dropped by 200. What should the ticket price be in order to maximize the revenue for the Opera House? And they said we can assume a linear demand curve. Okay, so here is your linear demand curve. So if you know that profit, so if, excuse me, I don't want profit, I want revenue. So let me get rid of that. So revenue is what they want to maximize, and revenue equals price times quantity. Okay, so let's see if we can figure out an equation here. So it's a linear demand curve. So what is the demand? What is the function? What does it look like? So, how am I going to figure this out? Well, I think the first thing I'm going to do is figure out the slope. So what's the slope of that line? So slope is rise over run. So let me just do that. Hold on, this pen's misbehaving again. So rise over run. So change in y over change in x. So 52 minus 50 over the change in x, so the 52 went with 3,800 minus 4,000. So that slope looks like 2 over 200, which if I wanted to write it as a decimal, and it's negative by the way, it's going to be negative 0.01, right? So it's 1 over 100, negative 1 over 100. Okay, so can I get an equation for that line? Well, let's think about this for a second. Well, if I was going to put it in point-slope form, what would I do? I would just say, okay, let's do that. I have this is negative 0.01. Let's work with some nice numbers. Why don't I say my y is 50? I'm just picking a point, and my x is 4,000. So x minus 4,000. If I distribute, so I'm going to leave this to you, but if I distribute that here, and then bring the y over, my goal is to get, and the y is really p, right? So p is going to equal what? When you solve that out, it's going to be 90 minus 0.01x. Okay, that is in what form? Slope-intercept form, and that's kind of what I need. So this equation is p equals 90 minus 0.01x. Okay, so let me take this. So I'm going to cut this out and put it over on the next page. And I'm going to say, okay, if that is my price, then my total revenue, so total revenue equals price times quantity, and in this case my quantity is x, so total revenue equals 90 minus 0.01x, right? The whole thing, that's all price, times x. So total revenue distributing equals 90x minus 0.01x squared. All right, so that's a quadratic formula. This is a quadratic formula that represents the revenue function. So now, finally, I'm ready to take the derivative and figure out how to maximize the revenue. So 90 minus 0.02x will be my first derivative. My second derivative will be minus 0.02. Since my second derivative is negative, I know I'm maximizing my revenue, so it's a max. All right, so the question was, what should the ticket price be? So have I gotten a price? No, I'm going to get an x value, and I'll get that x value when I set the second derivative equal to 0. So when I set this second derivative equal to 0, what I end up getting, and I'll let you do this step as well, is x equals 4,500. So remember, x is not the price. X is how many people are buying the tickets. So how do I get the price? I'm going to go back to my price equation, which was right here, and let me change color so that it stands out a little bit more. So since price equals 90 minus 0.01x, when you put this x right in here, you will get that the best price to maximize revenue is going to be $45, and that's your answer. So they did not ask us to do a formal test to make sure that it's a max, but we've already done that informally by just taking the second derivative and getting a negative value. Okay, so that takes care of question 14, and now we're going to do an economic order quantity problem in number 15. Okay, question 15 is telling us a furniture store expects to sell 640 sofas at a steady rate next year. The manager of the store plans to order these sofas from the manufacturer by placing several orders of the same size spaced equally throughout the year. The ordering cost, okay, so we're going to need this. The ordering cost for each delivery is $160. And carrying costs are based on the average number of sofas in inventory, and they are $32 per year for every sofa. Okay, so it says let X be the order quantity. So X is the order quantity, and R is the number of orders placed during the year. Find the inventory cost in terms of X and R. So let's think about this. So first off, we know that the inventory costs will always equal the ordering cost, so the OC, plus the carrying cost. All right, so what do I know? Ordering cost is $160 per delivery. So 160, and the delivery means the number of orders, so times R. Plus carrying cost is $32 per year times for one sofa, and it's based on the average number. So it's 32 times the number in your order over 2. All right, so that's my setup. Now, clearly I can put the 2 into the 32 and get the 16. So let's go ahead and I'll do that. So my inventory cost will equal 160R plus 16X. Okay, so that's the answers the first question. Then they say find the constraint function. Well, the number of sofas they need per year is 640, so 640 has to be equal to the number of orders they place every year times the number of sofas in the order. So 640 equals X times R. So if I want to, let's say I substitute out for R, I could then use my constraint to say that R equals 640 divided by X. So the next piece of this, they say determine the economic order quantity. So that's just a fancy way to say they want both the R and the X. And of course, they're going to minimize their inventory costs. And then they want me to also find what is that cost. So I need to do a couple of things. I need to find R and X, okay? And I have to make sure it's a minimum. And then once I find R and X, I want to figure out what the inventory cost is. Okay, so that's our mission. Okay, so let's start. Inventory costs equals, so I'm going to use my constraint once I get to the X. So I have 160R plus 16 times 640 over X. So I can rewrite that, and I'm going to say IC equals, I'm not taking the derivative yet, so I still have, let's see, let me just look at this for a sec. Okay, so let me just redo this because I've once again lost my little head. Okay, so let's try this again. So looking at my objective function, I have 160R, so it's 160, I'm replacing the R with 640 over X plus 16X. Okay, so do your little multiplication and you should be getting 102,400, and then bring your X up, X to the negative 1 plus 16X. Okay, now take your derivative, so change your notation. IC prime is going to be negative 102,400 X to the negative 2 plus 16. Okay, that has to equal 0. So when I do that, I'm going to end up getting 16. So let me just put a little line here. 16 equals 102,400 over X squared. So multiply the 16 times the X squared, divide by the 16, you get X squared equals 6,400. Take the square root of both sides, knowing that you can't have a negative. X will equal 80. Take that X, so X equals 80, and figure out what your R is. So if you put 80 into this R equation right here, I'm going to end up getting R equals 8. Okay, R equals 8. So next thing I'm going to do is I'm going to come up to my cost equation, and that was, let's see, probably the easiest one to use. I'm just going to change to red, is this one. Here is my cost, my inventory cost. So plug in the R is 8 for this R, and the X is 80 for this X, and you will get inventory costs equal to, let me see, 2,560, and that's dollars, 2,560. So what this basically is saying, given the fact that your carrying costs are based on average, you want to make 4 orders a year, and every order will have 80 sofas. If you do that, then you're going to have inventory costs of $2,560. And that ends the first part of this problem. Now they say in D, redo your problem assuming that carrying costs are based on the maximum inventory during the reorder period. So that means that where we divided by 2 here, we will not do that. So let's redo the problem on the next page and answer what they're asking us to do in Part D. Okay, so here I set up Part D now. So as I said earlier, the big difference here is that your carrying costs are now based on the total number of sofas in your inventory. So that impacts this term here. It's no longer divided by 2, making it 16x 16x for the carrying costs. It's instead 32x. So let's see how this impacts our problem. R is still 640 over x. Nothing else has changed in the problem. Okay, so we're going to do our little replacement again. So inventory costs equals 160 times 640 over x plus 32x this time. So inventory costs, once I do all that multiplication, I have 102,400 x to the negative 1 plus 32x. Okay, I'm going to take my derivative, and I get negative 102,400 x to the negative 2 plus 32. Set that equal to 0. I get 32 equals 102,400 divided by x squared. X squared equals 3200. X equals 56.57. Plugging x back into r over here gives me an r of 11.31. Clearly we're not going to really use the decimals, but we're going to leave it there just for argument's sake. But it looks to me like we're probably going to end up having 57 couches in each of the, probably 12 orders, something along those lines. So how has this changed? Previously, we had fewer orders because we were willing to store more because the storage cost was less. So to answer question E, it says compare your results given the different carrying cost structures. So I would say that when carrying costs are based on the maximum inventory, less is ordered each time. And that's because it costs so much to store the quantity that you've ordered. So the key is order less each time and place more orders per year. So I have not written that down, so just go ahead and write down what I just said, as long as you understand that. If not, rewind and listen again and make sure you can make sense of the different scenarios that have been portrayed in this example. Problem 16 says a small tie shop sells ties for $3.50 each. Okay, so that is your price. Okay, so they're selling it for that much each. So that's a price. The daily cost, okay, here comes a cost, function is estimated to be CX dollars, where X is the number of ties sold on a typical day. So here's my cost function. Find the value of X that will maximize the store's daily profit, or another term. Verify that you found an X value that will maximize profit by analyzing the second derivative. Remember that revenue is price times quantity. So let's see. We want to maximize profit. So what does profit equal? So profit has to equal the total revenue I make minus how much it costs me to make that revenue. So what's the revenue? Well, the revenue is going to be the price of the tie. So, and this is profit, not price, this P. So the price of the tie, which is $3.50, times the number of ties I sell. So I sell X ties. Minus, now you're going to minus the costs. Now, be very careful, because notice, you have multiple terms here. It's not a monomial, so you have to use parentheses. So the costs they established are 0.0006 cubed minus 0.03 x squared plus 2x plus 20. Okay, that's my profit equation, and my job is to maximize profit. Okay, so notice that we don't have a linear demand curve. We have a straight demand curve because this is a small shop. So his actions do not impact the price, and therefore it's just a straight up price times quantity situation. So shall we clean this up? So my profit's going to equal, so I have 3.50x minus 0.0006 x cubed, and there's a decimal point here. Now minus a minus is going to be plus, so this is where people tend to mess up, so don't be that people. And then minus a plus is a minus, and then minus again is a minus. Okay, so that's my profit equation. Now we're ready to take the first derivative. Remember, this P stands for profit and not price. So first derivative equals, and I could have done some subtraction, but I think I'll just do it later. So I have 3.5x minus, so this is going to be 0.0018x squared plus 0.06x minus 2. So, and I apologize, I don't need an x here. Okay, so let me clean this up again now that I can do my little combining terms. So this is really just going to be 1.5 minus 0.0018x squared plus 0.06x. Okay, so that is my function. So that's my first derivative. I might as well go ahead and take the second derivative now because they told me I'm going to do a second derivative test. So P prime prime equals, and that's going to be a negative 0.0036x plus 0.06. All right, so I have everything I need, and we'll probably take these two equations and work with them on the next page. So let me just cut these out. And put them here to work with. Okay, so this first derivative is going to be set equal to 0. Now, I am probably not going to think about factoring just because I may have to give it a lot of thought. So I'm going to go ahead and use the quadratic formula because I know that that's going to always work. So with that in mind, I'm going to say that x equals plus and minus, well, negative b, so 0.06 plus and minus the square root of 0.06 quantity squared minus 4ac. So when I do that, I'm going to end up getting plus, and you can just verify this, 0.1 over 0.0036. Okay, so I'm going to clean this up. This is going to be 0.06 plus and minus, and that ends up being 0.0136 over 0.0036. And as I work it through, I get x equals 50, so I probably could have factored it. So x is 50 is what I'm getting. So that means that if I sell 50 ties a day, I will maximize my profit. Now remember, we have to first talk about the second derivative test before we can say that we're done with this problem. So let me just grab this right here, and we'll take that over to the next page. Okay, so there I have it. So now I had said that my x equaled 50, so my p prime prime of 50 ends up being what? Let's see. When I do all the math, I get negative 0.12. You can verify that. And since that is less than 0, I'm going to have a max. So I would say at CV equals 50, the second derivative evaluated at 50 is less than 0. Therefore, my function is concave down, which yields a max, and in this case, it yields a maximum profit. Okay, so 50 ties will do it. And now we're on to the last problem. Okay, in this problem it says the demand equation for a monopolist, so here you have a downward sloping demand equation, is price equals 200 minus 3x. And the cost function is this, and that is in play when x is between 0 and 40. Determine the value of x and the corresponding price that maximizes profit. So first off, we need to remember that profit equals total revenue minus total cost. So what's total revenue? Total revenue is price times quantity. So the quantity is x, the price is 200 minus 3x, so therefore the total revenue is 200x minus 3x squared, because that is price times quantity. Okay, so you're going to take that term and you're going to subtract away your cost. And because you have more than one term here, I'm going to put it in parentheses so that I distribute that negative correctly. Okay, so now I have an expression for profit. So profit equals total revenue minus cost. Written in terms of x, it's total revenue, the first expression, minus total cost, the second expression, in parentheses. So if I clean that up and combine like terms, and I'll leave you to make sure I'm doing this correctly, but I'm getting profit equals, let's see, 120x minus 2x squared minus 75. So just make sure that you're getting the same thing. I'm just going to erase this. Okay, so now we'll continue. All right, so if that's my profit and they want me to determine the value that maximizes the profit, I'm going to need P prime. And don't forget that this P is profit. So that's going to equal 120, because it's a quadratic, so I'm expecting a linear term, minus 4x. So why don't we go ahead and do the second derivative, which is going to be minus 4. So that's telling me if this is a negative second derivative that's independent of x, because there's no x value there, what I am finding will always maximize the profit. So what x do I get if I set the first derivative equal to 0? It looks like I'm getting an x of 30. Now, this is the situation where you have to make sure you're answering the question. The question is not just what is x. It also says find the corresponding price that maximizes profit. So go back up to the top and it says price, and this P is price, equals 200 minus 3x. So if you put this x in for that x, you will end up with price equaling $110. Okay, and that answers that part of the question. Then the next one talks about imposing a tax. So we're going to talk about that on the next page. Okay, in the second part, it's saying, suppose that the government imposes a tax on the monopolist of $4 per unit quantity. So what is this tax? This tax is going to be another cost. So that is 4x. So that means that the total cost not only equals this, but you have to add another 4x in here under costs. Okay, so with that in mind, let's rewrite this profit equation. So profit now equals, I still have the same revenue. That tax did not impact the revenue. it does impact the cost. So minus, keep your parens, 75 plus 84x, not 80, but 84x, minus x squared. Okay, so cleaning that up, I'm getting profit, and don't forget you've got to distribute that negative very, very carefully. So profit ends up equaling 116x minus 2x squared minus 75, still a quadratic. I need to figure out how I maximize profit in terms of my quantity. So that's going to equal P prime is 116 minus 4x. So this time what happens, when I solve for x is now 29. And when I solve for price, so take that x and put it back in the original price equation that was at the top of the problem, the price ends up being $113. So what happens when the government imposes a tax on this monopolist? So looking at the previous price and quantity, they are now only producing 29 units of goods, whereas previously they produced 30. So they decreased their production, and their price went up by $3 because it was $110. Now it's $113. So that's how you incorporate a tax. You view it as another cost, and then that's how the monopolist is going to view it, and he's going to react accordingly. So that's the end of the review. So go back and listen to whatever you need to listen to make sure you can master this test.